It is also stuck to the oil via a compound. Prevents the iron from clumping and separating from the oil. At the center of the magnet, the net electromagnetic force is zero because it's pulling in every direction simultaneously. As ferrofluid leaves the magnet, the hole where there's no ferrofluid gets bigger and bigger. Here, the force of magnetism on the ferrofluid is stronger than gravity. However, it only gets strong enough to counteract gravity at the very closest. Notice the many rings of spikes. A nail can also function as a platform for spikes. Here, the plastic cover does nothing to interfere with the magnetic field. Eventually, when the magnet pieces touch, the force of friction is strong enough to stop the plastic from moving. Now here is the same strong magnet, but this time with more ferrofluid on either end, which makes a ball-like shape. Also, since all contact points have oily ferrofluid on them now, there is even less friction than before. When the magnet comes over, you can see which side is the North Pole and the South Pole. The strong magnet's field reaches the weaker magnet and pull each other towards him. The reason this is hard to grasp is because it is a liquid, so it can flow away from you, and yet it is also attracted to the magnet, so it doesn't all leave. All of the small pieces of iron want to be on the magnet in the field, and they resist other objects there. The field goes from positive to negative all over the magnet. However, it is strongest at the poles, so that is where the ferrofluid naturally congregates. Next, I will talk about why this oil makes a prismatic effect. To understand that, let's first talk about the reflection of light on glass. Light in quantum mechanics has a probability of doing something. We can't predict accurately whether a certain photon will do that, however. I would recommend reading the pictures, pausing as needed. At certain thicknesses, the stopwatch points in a way to cancel out probabilities. If you've ever seen diffraction grating, it uses properties of quantum electrodynamics, which describe all phenomena except gravity and nuclear physics. Diffraction grating amplifies light by blocking it from certain places where you wouldn't expect it to be normally. Usually, the probabilities cancel. That is because the arrows on the stopwatch point in radically different directions due to their increased time compared to going through the center. Because they're facing different directions, they mostly cancel. However, in the center, they're all facing the same direction, so they amplify. This makes a beam of light, which is why when you have a single slit, the light spreads out a bit, as not all of the light can get through. If you'd like to look it up, Huygens principle explains diffraction through slits rather nicely. With this knowledge, you might understand this picture a bit more now. Now, hopefully you've read the rest of the pictures and understand this. If not, you'd better start reading. Now I will recap. The tiny differences in the thickness of the oil affect how much light is reflected. The percentage of light reflected varies from 0 to 16% and depends on the thickness of the oil and the wavelength of the light. This is the end. The book I was using is called QED if you have any questions pertaining to that.